actually one of my favorite courses too, because you can always laugh at everyone else in the class. Being the professor of my interest, we'd laugh at everyone else in the class because they didn't know basic algebra. I think I was the only math teacher in that course, and I think I was taking Calc 3 at the same time.
Well, I feel like I told you this, but like, I like history, so I took a history class as my elective last semester, and there were history majors in that class, and I think I was one of like 2 people that ended with 100.
Triple integrals.
Oh, cafeteria was closed.
Oh yeah, it's too late. I think it
Oh,
closes.
he got here.
I think it closes after 4.
By the way, he did know that.
Yeah, I figured.
I would not.
Yeah, he did. He was just like, I'm gonna
I wasn't sure if it was open board.
just for that, just for that, I'm giving you an extra 6 points on the exam.
Well, you know
Thank
what?
you.
It's shit.
I appreciate that.
I'll take those 6 points from him, because he fell for it.
Okay.
No, don't do that. I seriously didn't know they were open.
So triple integrals. Obviously, it's a triple Riemann sum. Again, we're not going to do that. That's just the definition. Fubini's theorems, there's 2 forms. Right, Fubini theorem for triple integrals is for a box. Order doesn't matter. And this is the strong form of Fubini's theorem for triple integration. Right, so this is visually what we're doing. So you can write triple integrals as an iterated integral, a double integral over the projection of the solid on the xy plane of the integral from the lower surface to the higher surface dz dA.
This is kind of a strange question, but the z, the bottom z that equals u1, is that the same surface as z equals u2?
No.
So they don't have to be the same shape?
Average value, right, corresponds 1 over volume of the solid times the triple integral of the function over the solid. If you want just volume of a solid, it's just the triple integral over that solid of the volume differential, right? dV is now our volume differential. A geometric interpretation of triple integration is a signed hypervolume, which is the 4th dimensional equivalent of volume. Right, so you have the first dimension is length, second dimension is area, third dimension is volume, fourth dimension is hypervolume.
So what would that quantitate?
Unless you're working in more than 3 spatial dimensions, nothing that you need to worry about.
So then is this
Other than, obviously, if there are applications of triple integrals, but those would be physical applications, not the geometric
Is
interpretation.
this like the same idea? Is that like if you're taking a double integral of no function, you get
That's just area, dA,
and then is this the same thing where if you're taking a
It's
double
fine.
integral or a triple integral
of dV, it's
volume?
fine. And then if you start to work with hypersurfaces, and you need to know a volume, you can either do a 4-level integral or a triple integral. Right, but again, how many people actually do that?
Yeah, probably.
Alright, so just like with double integrals, so this would be like a double nested, right, or a double iterated. And this is how we represent. Right, as always, you work in, outwards. Right, so like the xenomorphs. Right? It's just like the xenomorphs.
What is triple?
Just iterated integrals in general. Starts from the inside and works its way down.
Chest versus. Still never seen it on my to-do list.
Again, I'm not going to be doing this for every problem. X, Y, Z antiderivative with respect to Z. It behaves the same way. X, Y is going to be treated as a constant, right? So it's a constant multiple of Z. So it's what? That constant times Z squared over 2. That's your antiderivative. Right?
So, could you break this up into 3 integrals, technically? Because can't you pull the constants out of the first integral?
You can't in this case because look at your limits for Y and Z. They depend on X.
I see. So if they didn't, then you can do that. And then just
But you could do the inner two as a product.
So you can pull that.
Right, because Z doesn't depend on Y.
Yeah.
So you could do those inner two as a product of two integrals.
So
One with Y, one with Z. But then the problem is now they depend on X. So you wouldn't be able to just do a
So I guess
triple
the,
product.
I guess the only time you can do a triple product is
Basically, it's a box. Like it's a constant limits. Wasn't that a scalar multiple times Y? In terms of Y? That's going to be the integral, right? We have to expand that. This is going to be what, a 5th degree? When fully expanded. Fun. I'll let you do the algebra.
Now, if you were given a triple integral on an exam, would you want us to go through all of the steps for it?
If I tell you not allowed to use a calculator. What's that antiderivative?
No one does this. It's going into snow.
I don't want the integral, the antiderivative. Which you shouldn't need a calculator for. So I don't want to evaluate it yet. I just want the antiderivative.
So that's 6x over 6 minus.
Where are you getting 6x from?
Or x to the 6th, sorry. X to the 6th over 6 minus 6x to the 5th over 5 plus 13x to the 4th over 4 minus 12x to the 3rd over 2 or over 3.
Which is what simplified?
4x cubed plus 4x squared over 2, which is 2x squared. And then that's just going to be
Which makes this very easy to evaluate,
yeah,
because it's 0 to 1.
1/6, 1/5, 13/4 minus 4 plus 2.
What's minus 4 plus 2?
Oh, never mind. Sorry.
Six times 5 times 4. Although I guess we could go, what's the LCM of 6, 5, and 4? If we're not doing calculus, the easy way to do it is just write them all in prime factorization. Four times 3 is 12, times 5 is 60. There's your LCM.
So what?
10 minus 72, thanks, it's 6 times 12, is negative 62. 13 times 15. What's 15 times 10? 150. What's 3 times? What's it? Oh yeah, 13 times 5 is 95. 150 times, or 150 plus 95 would be 245. 245 minus 65. And then minus 120. That doesn't sound right.
2195.
That's not what I have in my notes, so I have no idea.
Well, 245 minus 625 is 180.
Let's do this in my head. Yeah, 1306. Ah, okay, yeah. No, I screwed up somewhere. Notice what I did? I dropped those two.
Oh, shoot. Yeah, it was looking important.
Should be a 1/2 out there. Ten multiplied by a quarter. Which is like 13 or 240. This is a case where you could do what you're mentioning, right? Product of the three. Because it's just a sliver of
So
a
that
box.
would end up being,
So what you could do is you could write it this way.
because would that just be taking 3 intervals then and just or multiplying another?
Could do that.
Would that generally be easier to do? Because then you're just taking,
No, I mean, it doesn't matter.
then you're just taking 3 intervals.
I mean, you're still doing 3 intervals. So it doesn't matter.
I feel like that's less to keep track of, I guess is what I'm saying.
Negative cosine theta from 0 to pi over 2. So it's cosine of theta. A third. Z squared over 2, 4 over 2 is 2. 2/3. Right?
Wait, could you go back? Wouldn't the integral z squared oh, no. I was trying to, I was trying to toss me out. Because it's 4 and
There's no theta anywhere, right? So there's going to be pi, right?
Oh, so if there isn't a variable that you're different or
Yeah, you just integrate with respect to that first. You're going to get pi, right?
because then it's pi minus 0, so it has to be pi. Oh, okay, I see. For a second, I thought you were just saying the whole triple integral is
No.
equal to pi, and I was a little confused.
No, it's just with respect to theta.
Gotcha.
Oh, but there's no rho either.
So same thing.
Try the 4, right? And that's just going to be that.
How do you do this? I'm forgetting the secant. Isn't it like everybody's?
Why does integral secant matter?
Because you're taking the secant of pi.
Right, but it's a product. It's the integral product. It's not the product of the integrals. That'd be integration by parts. So I mean, you could do that if you wanted to.
You lost me.
But you don't want to integrate just secant.
No.
So what the integral secant is doesn't matter right now.
But would you not need to take its integral? Like you're using product rule here. So it's
Does integration have a product rule?
oh right.
It does, but it's called integration by parts.
Okay. Yeah, show me what you're doing in this case. So why is the secant just picking pi? Or I guess where did you get the other
Double angle for sine. Sine of 2 phi is 2 sine phi cosine phi. Secant times cosine is 1.
This is why I don't trig. Trig is easy.
This is why I love trig. Trig is sexy.
Would you figure that? Like, am I crazy here? Would you figure that out?
I mean, no, I wouldn't have known that identity, but I would have.
Trig is sexy.
That's objective.
If you know how to use it, it's sexy.
And by the way, you're right. It is objective. It's a fact. I think you meant to say it's subjective.
Oh, did I not?
You said objective.
Oh.
You're right. It is objective. Safety agrees with me. Trig being sexy is
No,
objective. It's
no,
a universal fact.
No.
It's a universal fact.
That's not true.
That's going to be negative cosine again.
Yep.
Cosine of 0 is 1. Cosine of pi over 4. There's your integral. 2 pi minus pi root 2, or if you wanted to just keep the pi alone, could write it as pi 2 minus root 2. Right, just didn't want to factor it out, we'll straight that pi from. And that's the stop.
That's crazy. So I guess taking multiple intervals isn't too terrible. I say that now, but I have a feeling.
And don't forget about your homework and group assignment, and I plan on handing the green sheets out for the last exam next week.
Due next Monday.
What is?
Assignment?
No, group assignments due the 4th of August. That should be 2 weeks.
Okay.
I think I glanced at the homework, we've got episodes, but don't quote me on that.
The one that was like 5 questions